Any angle that we have marked on the unit circle as nice special angles, it's easy for us to find sine and cosine. So if I told you to, as an example, let's say that I wanted to evaluate 2 times sine of pi over 6 times cosine of 2 pi over 3. That's something that I can do pretty easily because I can come in here and sine of pi over 6 would be the y value at pi over 6. So pi over 6, the y value is 1/2. And then cosine of 2 pi over 3 would be the x value at 2 pi over 3. So I go to 2 pi over 3. The x value is negative 1/2. 2 times 1/2, it's going to cancel. And so I would end up with negative 1/2, and I would be done. So expressions involving nice angles on the unit circle are easy for us to work with. The problem comes when I say evaluate something like cosine of 7 pi over 12. Is that on the unit circle? The answer is yes. So it is not one of the nice angles. If you go find 7 pi over 6, which is right here, okay, that is a nice angle. And so that angle right there, 7 pi over 6, well, 7 pi over 12 would be half of that. So if I took that angle, divided it in half, I'd end up about right here. And I know that may not look like half, but that's where it is, okay? And so if you actually mark it, you can see that that is, if I go this way and this way, it's the same rotational distance, okay? And so this is the angle we need to find. Well, we can't find this directly though, because that's not a nice angle for us to evaluate. So fortunately, we have mathematicians who have been cranking away with the properties of sine and cosine for hundreds of years, and they found out that there is an identity that allows us to evaluate this directly. Well, the first set of identities that we're going to be looking at are the sum and difference identities. Of sine and cosine. And you can look at them in Khan Academy. They're listed there. I'm going to write them a little bit differently because the way that they're written on the study guide that I'm giving you on the website is this way. And so you should be familiar with what it means. So for sine, turns out that you can find the sine of 2 angles added together by calculating the sine of the first angle times the cosine of the second angle, and adding to that the cosine of the first angle times the sine of the second angle. So it's a special relationship that you can actually prove using geometry. We're not going to prove it because of the time, and normally we would, but not when you guys are working from home. There is a proof in Khan Academy. If you're really curious, you can actually go. It's not assigned, but there is one of the units that I skipped over that is a proof of the law, or of the addition identity. He calls them the addition identities, but most people I know call them sum and difference identities. And it turns out that if you wanted to do subtraction, you just change this to subtraction. Okay, so this is the way I write it because it's short and sweet. You don't have to write two different identities for addition and subtraction. There's also an identity for cosine. And for cosine, it's a little bit different. If you add two angles together, you can calculate the cosine of that by taking the cosine of both angles multiplied together. And here's where cosine is different because it's shifted 90 degrees from sine. It's going to subtract the sines multiplied together. Okay, and so that is the identity for cosine. So when you add them, you end up subtracting. And so for subtraction, so if I wanted to do subtraction, what do you think this is going to turn into? It's going to turn into plus. Now the problem is notice that these are reversed from each other. So the way we show that is this one is plus or minus. This one is written minus plus. And those are actually two mathematical symbols that are commonly used. They're special symbols. They're available in the character map on Windows. So this means that these are always opposite each other. So these would be the sum and difference identities for sine and cosine. So the fact that this one and this one are upside down from each other means that if this is plus, this is minus, and if this is minus, this is plus. Okay? And that way we don't have to write two identities for something that's so similar. They're really the same. For both addition and subtraction, they have the basic form. It's just those pluses and minuses get switched. So we can actually solve this one now. You may not realize it, but this unlocks this problem. But here's where students struggle. They're like, well, I'm not seeing how that helps me out here. There's not two angles there. So what we need to do is take that 7 pi over 12, and we need to rewrite it as two separate angles. And the trick, remember that when you add things, they have to have the same denominator. Okay. So what two numbers add together to be 7? 5 and 2. Does 5 reduce with 12? So 5 doesn't reduce with 12, so don't use that one. Does 3 and 4 reduce with 12? Yes. So that would be one possible thing that you could use. So you could use 3 and 4 pi. And by splitting 7 pi up into 3 pi and 4 pi over 12, this is the same as this, but I can simplify these. So this would be pi over 4, and this would be and pi over 3, which are two nice angles. So pi over 4 and pi over 3 are very nice angles on the unit circle. And so what we're going to do is we're going to rewrite this problem as the cosine of pi over 4 plus pi over 3, because we know that those two added together is this angle. And now we do have the ability to work with this problem because I have an identity that tells me how I can split cosine of two things added together up. I can use this equation. So it's going to split up as cosine of something times cosine of something. Is it going to be plus or minus? Is this plus or minus? And here, if plus is on top, what's on top here? Minus. So it's going to be minus. So that's why these are reversed from each other. So that when you look at this identity, If that plus is on top, if you have a plus, then it'll be minus. If you have a minus, it's on the bottom, so it'll be a plus here. And then we have sine of something times sine of something. That's this identity right here. So we're using this identity right here. And now I'm going to change colors to emphasize, because I need to keep track of one of these angles and the other angle. So pi over 4 is the first angle. And if I look, everywhere the first angle appears here, I need to put it in up here. So the first angle and the first angle. And then the second angle, so that's my second angle. So beta and beta. And now I have the ability to evaluate these using the unit circle, because all of these are nice angles. So cosine of pi over 4 is going to be something. Cosine of pi over 3 is going to be something. Sine of pi over 4 is going to be something. Sine of pi over 3 is going to be something. So then cosine of pi over 4, cosine depends on x, so root 2 over 2. Cosine of pi over 3, that would be 1/2. Sine of pi over 4, so pi over 4 root 2 over 2, because it's y. Sine is y. Sine is y, so pi over 3, y value is root 3 over 2. Okay. And if we multiply each of these pairs of numbers together, that would be root 2 over 4 minus root 2 times root 3. So what is root 2 times root 3? Remember that powers are really a repeated form of multiplication, and a root is just a rational power. So you can just multiply them together. And then 2 times 2 is 4. We wouldn't leave our answer this way, though. We would write it differently. So one way of writing this answer would be root 2 minus root 6 over 4. And that would be a perfectly mathematically justifiable answer. This is what I would consider the nicest answer. It looks the nicest. I've seen books write them many different ways. This is the convention that I find to be the simplest and easiest to work with for most students. Okay. Now, it turns out that this is exactly the same as something else, though. And I need to explain to you why it's the same. So though the answer we got may look nice, it's different from what Khan Academy has. And let me show you why and how you can actually match them up. So I'm going to start here with the answer that we just got, which was root 2 minus root 6 over 4. Now, if we look at this, it's a nice answer. It's rationalized, so no roots in the denominator, but we need a way to match this answer that we got with what Khan Academy is actually going to provide you in their multiple choice. So if we go and look at this piece, we can actually multiply this by a number so that one of these is no longer a root. And the number we can multiply by would be square root of 2. So if we multiplied top and bottom by square root of 2, then root 2 times root 2 is square root of 4. Root 6 times root 2 is square root of 12. And then 4 root 2. And so then if we look at what we have, well, that's just 2. That can be written as square root of 3 times square root of 4. The bottom can't really be changed. And then if we look, root 4 is just 2. So I'd have 2 minus 2 root 3 over 4 root 2. And there's a 2 in all of these, so I can reduce. And I end up with 1 minus square root of 3 over 2 root 2, which, though it's not as pretty and it's not rationalized, it is actually the same as the answer that we arrived at. So be forewarned that this is the same as this. And if you see an answer like this and it doesn't match what you got when you calculated it out, you can take whatever you started with, look at what's different. So like this 1 right here, I really want a root 2 there. So if I take this, multiply top and bottom by square root of 2, I can work backwards. So root 2 times 1 is root 2. Root 2 times root 3 is root 6. That would be root 2 times root 2, which is 2. So 2 times 2 is 4. So by multiplying top and bottom to rationalize, I get back to the answer that we had. Both of these answers are technically correct. One of them is not rationalized.